All right, requirements development. People talk about user requirements, where there you've labeled the requirement by its source. Everything I'm talking about this afternoon is solution requirements, right? So a solution requirement is a restriction that determines whether some solution you come up with is adequate or not. So are you conformant with the HIPAA requirements on privacy, right? So are your data sets such that I cannot determine which of my which of my patients have which diseases? They got to be separate and non-resolvable. If both of those data sets were somehow stolen, it should not be possible for the stealer to make an association. That's a HIPAA requirement. Okay? So you can have the most beautiful system, everything's working, except that's not true. Okay? You want to know all the restrictions, right? A proposed solution may comply with all the requirements you know about, but still be inadequate because the things that you know about aren't complete. There are important things that you don't. So you never stop learning. And when you get into new domains, space station, nobody's got experience in that domain. Nobody's got experience in autonomous vehicles. I mean, there have been people who have worked in this for a decade or more. But they are still discovering a lot of interesting things. They're coming to appreciate how incredibly powerful you and I are, our little human brains. And now my 18-year-old or 19-year-old, their brain isn't fully formed yet. I'm really worried about them on the road, but anyway. So some believe that poor requirements are a leading cause of project failures. That's why any of this stuff this afternoon is important. Some people don't believe that. Poor requirements cause this stuff. 54% of the requirements faults on space station were things that people didn't get. You would expect most of the things to be there because nobody had any experience. And so all they could do was imagine. That's why Albert Einstein talked about that imagination is much more important than knowledge, right? If you want to get to the next level of something, do something that's never been done before, you got to imagine. You got to have a wonderful imagination. And you have people who say, no, that'll never happen. Right. Only it'll wait for the second day that the system is in place. Good requirements matter. Simplistic models don't help. The goal of requirements development. What I would like to do without the Vulcan mind meld is I want my team to have a deep, synchronized, and accurate understanding of what we need to do. Synchronized. That means everybody's in the community has got a similar image. Oh, look at that. How wonderful it is. Well, wait a minute. Why are penguins imagining tire swings? Okay, this is what I want. This is rare. This image with human beings there are even rarer. That everybody is literally on the same page. We use that phrase so easily, but it's incredibly hard to get it because we all have a lot of stuff going on inside our head that causes that not to be true. Okay, so here, the third model was the basic pattern of actual software requirements development itself. So the first thing, the simplistic model says elicit. This model says acquire, because there are about 20 different ways to acquire information about what we want to do. When I came back from teaching overseas, I went to work for a company. They handed me a listing, and I said, yes, what am I supposed to do with this? They said, understand it. So I was much more naive then than I am now. I said, okay, I sharpened up my 3 number 2 pencils, and I took out my template, flowchart. I think I was just going to flowchart my way into understanding. Well, that didn't work. This particular listing had a go-to density that has never been surpassed. It also used completely meaningless labels for everything. For the sections, for the data, nothing. And so after I told my manager I'd have it done in a week, and I went back after 3 days and said, I think we're going to have to adjust that. I have no idea what I'm going to get done. And I started having to move lines of code around, having no idea what they did, but there was a go-to here, and it jumped up here, and then it jumped back there, and I thought, wait, why can't I just move this and get rid of those go-tos? And sometimes it worked, and sometimes it didn't. And it's only until I began to straighten out some of the strands of spaghetti that I began to think I understood maybe what this code was doing. 3 months later, I went to my manager and I said, I understand it. He said, good, and your prize is to rewrite it. Right? So that's one way, a very painful way of figuring out what the requirements are by reverse engineering, in this case, an incredibly opaque set of code. That's just one of 20 different things to do. Yes, asking the users is incredibly important, but that's just one of those 20. Then you got to analyze what you got, because sometimes we have conflicts. Many of you are aware of security and usability. Now, maybe you enjoy answering the 3 security questions that you could barely remember what you claimed the answers were. I don't, and I don't find it increases the usability. But I know I have to get through this wall that they've built in order to get to, hopefully, a much more usable piece of software on the other side. And sometimes there are derivations. If I discover that I have to do safety, from that responsibility becomes hazard analysis. I got to figure out all of the things that can go wrong. I once worked for a company in town as a consultant, and I was mightily impressed because the first thing they did was have a senior engineer write down all the ways that the device they were concerned about could kill people. And it was a very long list. And I went, wow, that's an interesting way to start the project, okay? Then they had to say, well, this can't happen because of this can't happen because of this. This can happen, but we can mitigate that by doing this. And so all the mitigations line up against all the hazards. All the hazards? Did we forget maybe 1 or 2? How do we know that we got them all? Well, we ask a lot of smart people to review the hazard list. We make it as public as possible to let as many people as appropriate look it over, and then we're still worried. And we keep our eyes peeled for something that none of us ever expected was even possible. Okay, now these things are all optional. That's what the square brackets mean. Why are they optional? Because if you're doing your nth reservation system or your nth billboard website, you have a lot of internal knowledge about what you need to know. You want to know whether your customer likes light green or tan. Why? Because you've learned over time that those are very good background colors, and you want to know what this particular customer wants. So you are driving a lot of answers. The customer doesn't even know why necessarily you're asking. You know much more. They just came to you and said, I need a billboard web. All right. They didn't even use the word, I need a website for my business. And immediately you have this big long list of questions that you need to ask them. But not what the requirements are for that. You know that. So that's why all these guys, notice the middle guy there, designing system architecture. Some of the people at the SEI, Software Engineering Institute, feel that knowledge of the quality attribute requirements is very important in selecting the architecture. Okay? Now again, we gotta give and take there, right? The architect might say, okay, these are 3 or 4 possible architectures. Let me see what information I can gather about the quality attributes. This is like security, performance, yada, yada, yada. There are over 60 of them. And then I'm going to winnow it down to 1. And then once you've got that one architecture, then you have 3 jobs, 3 strategies you need to develop. 1 for each of the quality attributes that you've identified for your system. How are you going to achieve it? How are you going to verify it? And how are you going to monitor it? We're in the age of complexity, folks, and think that you all know this, and it's not getting any simpler. So we actually have to monitor stuff after we think we've done everything that needed to be done, right? We claim we achieved it, we claim we verified it, and then we have unanticipated acceleration. What? We're back in the automated vehicles again, but we're just starting. I did a little research and discovered that unanticipated acceleration has been around since 1940. Now, there wasn't much software inside the cars there, but for some reason, they would accelerate without anybody putting their foot on the accelerator. And now we've got software-based stuff. And now somebody in Florida is tearing down a freeway at 2 in the morning, and his BMW is accelerating 80, 85, 90, 95. Now he's got, something akin to, forgot the name of the system that GM has, but whatever, they're talking to somebody, right? And the somebody says, have you turned the motor off? Have you turned the key? Yes. OnStar, thank you. So it's not OnStar, but it's akin to that, whatever the BMW folks call it. Anyway, so he's talking. The person on the other end of the line is talking, asking if he's done all these things. He said, I put it into neutral, I've turned it off, and it's still accelerating. And they notified the police, and the police put down these tire scramblers on the road, and for reasons I have never understood, he drove around the first one, or the car did. I don't know, maybe he wasn't in control. Then they put some more down a quarter mile further, and it went over that, and a quarter mile later, it stopped and started to smoke. And he got out. Now, after kind of a harrowing experience like that, how would you feel when the representatives of BMW said, oh, that can't happen? We've got very smart software engineers who have put code in there to check what's going on. So it's not possible. You must have not done one of those things that you claimed you did. Ooh, I would just kind of run out to my BMW dealer and get a new one. If you take nothing else away from this afternoon, folks, here's the bottom line. You've got to respect complexity, which means that the systems you're building may do things that you have no idea how in the world. I mean, it wasn't, I did a function and it did something else. I'm talking about some really serious misbehavior on the part of the software for reasons you don't understand. The Therac 25, a device out of Canada, killed 4 people before they discovered what was going on. And they only discovered what was going on because it killed 2 people at one hospital. And what they found was that when an operator of this device set it in motion and realized that it had been set in the wrong mode, which was in the manual, what you're supposed to do when that happens, and they did it. But when they did it the first year the device was there, everything worked great. When they did it the second year, those operators had become very familiar with the device. And so they were able to type the switchover commands much more quickly. Their typing speed caused a buffer overflow and set the device into a death state. Who's going to figure that out beforehand? Right? So you need software in there that says, excuse me, you can't get into the death state. I don't care what else is going on in the device. When it comes down to here and you're going to slide the lead shielding off of the radiation source, which is set to high, you're not going to do it. Right? A whole separate monitor, separate from anything else that's there. You can't imagine how that code will ever execute. Of course, you got to make it execute and test to make sure it actually works. But it doesn't matter whether you can imagine how. In the face of complexity, you go, I'm sure there's a way. Let me make sure we don't kill anybody. Okay, how do we acquire this information? I already talked about reverse engineering. We can watch something, do association, derivation, and generalization on what we've got, etc., etc., etc. Nice long list. Only half the list, we analyze all this other stuff. There are lots of ways to get information, requirements-related information. Now, not all of these are going to be relevant to you. This is my favorite book in requirements. Of these 20, it maybe catches 12 or 13, but is the best by far of anything that's out there. Now, the bad news is, when you're doing really complex systems and you've never done it before, requirements is a never-ending story. You're going to discover stuff. You need to have a system set up to capture the stuff. Yes, there will be the first weeks, the first months, whatever, but then in the second year, remember the Therac 25, something might happen that has never happened before, and you need to be on top of it. React quickly, figure out what it was, figure out what changes there need to be made to the system, yada, yada, yada.